Hello everyone, my name is Pooja Mishra, college roll number 205076. My presentation topic is graph theory. Introduction. In the domain of mathematics and computer science, graph theory is the study of graphs that concerns with the relationship among edges and vertices. It is a popular subject having its application in computer science, information technology, biosciences, mathematics, and linguistics, to name a few. Without further ado, let us start with defining a graph. What is a graph? A graph is a pictorial representation of set of objects where some pairs of objects are connected by links. The interconnected objects are represented by points termed as vertices, and the links that connect the vertices are called edges. Formally, a graph is a pair of sets V, E, where V is the set of vertices and E is the set of edges connecting the pairs of vertices. Take a look at the following graph. In the above graph, the set of vertices V is A, B, C, D, E, and the set of edges is AB, AC. Here AB, this is A to B, and AC, BD, CD, and DE. These are edges, and A, B, C, D, E are vertices. Fundamentals of graph theory. Point. A point is a particular position in a one-dimensional, two-dimensional, or three-dimensional space. For better understanding, a point can be denoted by an alphabet. It can be represented with a dot. For example, here the point A is represented as a dot. Now, line. A line is a connection between two points. It can be represented with a solid line. Here A and B are the points. The link between these two points is called a line, that is AB. Vertex. A vertex is a point where multiple lines meet. It is also called a node. Similar to points, a vertex is also denoted by an alphabet. For example, here the vertex is named with an alphabet A and denoted by a dot. Edge. An edge is the mathematical term for a line that connects two vertices. Many edges can be formed from a single vertex. Without a vertex, an edge cannot be formed. There must be a starting vertex and ending vertex for an edge. For example, here AB is edge, where A and B are the two vertices and the link between them is called an edge. Graph. A graph G is defined as G is equals to V, E, where V is a set of all vertices and E is a set of all edges in the graph. Here, this square is a example of a graph. Here AB, BD, CD, and AC are the edges, and A, B, C, and D are vertices. Loop. In a graph, if an edge is drawn from vertex to itself, it is called a loop. Here the given figure shows a loop. In the above graph, V is a vertex and for which it has an edge V, forming a loop. Example 2. In this graph, there are two loops which are formed at vertex A and vertex B. Here you can see there are two loops which are formed at vertex A and vertex B. Degree of vertex. It is the number of vertices adjacent to a vertex V. Degree of vertex is denoted by DEG in bracket capital V. In a simple graph with a n number of vertices, the degree of any vertices is degree V is less than or equal to n minus 1 for every V belongs to G. A vertex can form an edge with all other vertices except by itself. So the degree of a vertex will be up to the number of vertices in the graph minus 1. This 1 is for the self vertex as it cannot form a loop by itself. If there is a loop at any of the vertices, then it is not a simple graph. Degree of vertex can be considered under two cases of graphs. First is undirected graph and the second one is directed graph. Degree of vertex in an undirected graph. An undirected graph has no directed edges. Consider the following example. Here in this example, we have taken take a look at the following graph. Uh, in the above unidirected graph, degree of A is equals to 2 as there are two edges meeting at vertex A. The two edges are AB and DA, which are meeting at A. Now degree B is equals to degree of B is 3 as there are three edges meeting at vertex B. Here you can see three edges that are AB, DB and CB. All the three edges are meeting at B. Degree of C is equals to 1 as there is one edge formed at vertex A. Here at C there is only one edge, that is BC. So C is a pendant vertex. Here from this graph, degree of D is equals to 2 since there are two edges meeting at vertex D that are AD and BD, which are meeting at vertex D. Degree of E is equals to 0 as there are 0 edges formed at vertex E. So E is an isolated vertex. Now degree of vertex in a directed graph. In a directed graph, each vertex has an in degree and an out degree. In degree of a graph, in degree of vertex V is the number of edges which are coming into the vertex V. Notation of degree of in degree graph is DEG minus V. Out degree of graph, out degree of vertex V is the number of edges which are going out from the vertex V. Its notation is DEG plus V. Take a look at the following directed graph. Vertex A has edge AE, that is this edge AE going outward from vertex A, hence its out degree is 1. Similarly, the graph has an edge BA coming towards vertex A, hence the in degree of A is 1. The in degree and out degree of other vertices of are shown in the following table. Here vertex A has in degree 1 and out degree 1. Vertex B has 0 in degree and 2 out degree. Here you can see vertex B has both degrees and both outward degrees. So here it has 0 in degree and 2 out degree. Vertex C has 2 in degree and 0 out degree. Vertex D has 1 in degree and 1 out degree. Vertex E has 1 in degree and 1 out degree. Properties of graph theory. Graphs come with various properties which are used for characterization of graphs depending on their structures. These properties are defined in specific terms pertaining to the domain of graph theory. In this chapter, we will discuss a few basic properties that are common in all graphs. Distance between two vertices. It is number of edges in a shortest path between vertex U and vertex V. If there are multiple paths connecting two vertices, then the shortest path is considered as the distance between the two vertices. Notation is D in bracket U comma V. There can be any number of paths present from one vertex to other. Among those, you need to choose only the shortest one. Example, take a look at the following graph. Here the distance from vertex D to vertex E or simply DE is 1 as there is one edge between them. There are many paths from vertex D to vertex E that are DA, AB, then BE. Second is D to F, F to G, then G to E. And the third one direct D to E. It is considered for distance between the vertices since it is the shortest path. Next one is D to F, then F to C, then C to A, then A to B, then B to E. And the last path is D to A, then A to C, then C to F, then F to G, and then G to E. Here D is the shortest distance, therefore it is considered for distance between the vertices. Central point. If the eccentricity of a graph is equal to its radius, then it is known as the central point of the graph. If EV is equal to RV, then V is the central point of the graph G. In the example graph, D is the central point of the graph. Here you can see through this graph that D is the central point. Hence, ED is equals to RD is equals to 2. Center. The set of all central points of G is called the center of the graph. For example, here set D is the center of the graph. Circumference. The number of edges in the longest cycle of G is called as the circumference of G. For example, in the graph, the circumference is 6. Here in this graph, the circumference is 6, which we derived from the longest cycle A to C to F, then to G to E to B, and then A, or A to C to F to D to E to B to A. Girth. The number of edges in the shortest cycle of G is called its girth. It is denoted by small g in bracket capital G. In the example graph, the girth of the graph is 4, which we derived from the shortest cycle A to C, then C to F, then F to D, then F to A, D to A, or D to F, then F to G, then F to G to E, then E to D, or A to B, then B to E, then E to D, or D to A. Types of graphs. There are various types of graphs depending upon the number of vertices, number of edges, interconnectivity, and their overall structure. We will discuss only a certain few important types of graphs in this slide. First one is null graph. A graph having no edges is called a null graph. For example, here this graph is a null graph. It has no edges. In the above graph, there are 3 vertices named A, B, and C, but there are no edges among them. Hence, it is a null graph. Trivial graph. A graph with only one vertex is called a trivial graph. For example, in the above shown graph, there is only one vertex A with no other edge. Hence, it is a trivial graph. Non-directed graph. A non-directed graph contains edges, but the edges are not directed ones. Here in this graph, A, B, C, D, E, F, G are the vertices, and A, B, B, C, C, D, D, A, G, G, F, E, F are the edges of the graph. Since it is a non-directed graph, the edges AB and BA are same. Similarly, other edges also considered in the same way. Directed graph. In a directed graph, each edge has a direction. In the above graph, we have seen vertices A, B, C, D, E, F, and G, and 8 edges A, B, C, B, D, C, A, D, E, C, F, E, G, F, and G, A. As it is a directed graph, each edge bears an arrow mark that shows its direction. Here you can see the arrows. Note that in a directed graph, AB is different from BA. Simple graph. A graph with no loops and no parallel edges is called a simple graph. The maximum number of edges possible in a single graph with n vertices is NC2, where NC2 is equal to n in bracket n minus 1 divided by 2. The number of simple graphs possible with n vertices is equal to 2nc2 is equals to the power n in bracket n minus 1 divided by 2. For example, in the following graph, there are 3 vertices with 3 edges, which is maximum excluding the parallel edges and loops. This can be proved by using the above formula. These 8 graphs are shown as below. The maximum number of edges with n is equals to 3 vertices, we find this as with the help of formula nc2 is equals to n in bracket n minus 1 divided by 2. Here we will put n is equals to 3. So we have 3 in bracket 3 minus 1 divided by 2, which is equals to 6 by 2, which is equals to 3 edges. Now the maximum number of simple graphs with n is equals to 3 vertices, the formula is 2nc2, which is equals to 2 to the power n in bracket n minus 1 divided by 2. Now putting n is equals to 3, we have 2 to the power 3 in bracket 3 minus 1 divided by 2, which is equals to 2 to the power 3, which is equals to 8. Connected graph. A graph G is said to be connected if there exists a path between every pair of vertices. There should be at least one edge for every vertex in the graph, so that we can say that it is connected to some other vertex at the other side of the edge. In the following graph, each vertex has its own edge connected to other edge. Hence, it is a connected graph. This graph is a connected graph. Now, disconnected graph. A graph G is disconnected if it does not contain at least 2 connected vertices. Cycle graph. A simple graph with n vertices and n edges is called a cycle graph if all its edges form a cycle of length n. If the degree of each vertex in the graph is 2, then it is called a cycle graph. For example, take a look at the following graphs. Graph 1 has 3 vertices. Here you can see it is a triangle, so it has 3 vertices with 3 edges, which is forming a cycle: AB, BC and CA. Here in the graph 4, it is a square, so it has 4 vertices with 4 edges, which is forming a cycle: PQ, QS, SR and RP. Here in this graph 3, it is a pentagon, therefore it has 5 vertices with 5 edges, which is forming a cycle: IK, KM, ML, LJ and JI. Now, cyclic graph. A graph with at least one cycle is called a cyclic graph. For example, here in the graph we have 2 cycles ABCDA and CFGEC. Hence, it is called a cyclic graph. Acyclic graph. A graph with no cycles is called an acyclic graph. Applications of graph theory. Graph theory has its applications in diverse fields of engineering. In electrical engineering, the concepts of graph theory is used extensively in designing circuit connections. The types or organizations of connections are named as topologies. Some examples for topologies are star, bridge, series and parallel topologies. In computer science, graph theory is used for the study of algorithms. In computer network, the relationships among interconnected computers in the network follows the principle of graph theory. In science, the molecular structure and chemical structure of a substance, the DNA structure of an organism, etc. are represented by graphs. Linguistics, the parsing tree of a language and grammar of a language uses graphs. Journal routes between the cities can be represented using graphs. Depicting hierarchical order information such as family tree can be used as a special type of graph called tree. Here comes the end of my presentation. Thank you.